I want to welcome everyone and thank you for joining today's webinar, Challenges of Multi-Vendor Systems and Implementation of IIoT-ready PLCs. This webinar is brought to you by ISA and Honeywell. I'm Michaela Cooper with ISA and I'll be hosting today's webinar. But before we get started, I'd like to review just a few housekeeping items to let you know how you can participate in today's session. First, in regards to the poll questions and the question and answer session, we do have 4 poll questions that will be coming up here soon at the start of this webinar. And when the poll questions pop up, we ask that you enter your answer into the poll feature on the WebEx navigation. This, as you can see, is on the right-hand side of your WebEx screen. This is completely anonymous, so feel free to join in, engage with us, and make this webinar as interactive as possible. Also, we do have one Q&A session at the end of this webinar, and to submit your questions, you'll want to type them into the Q&A box on the right-hand side of the WebEx screen. We ask that you do not use the Q&A box for miscellaneous questions. We're going to try to keep all of our Q&A session questions into that Q&A box. So any miscellaneous questions for me, submit those into the chat box. And if we do not get a chance to respond to your question, or if you'd like to discuss a topic in more detail with the presenter, their information will be given at the end of the webinar, but we'll try to get through as many of the questions as possible. Second, for those of you who just joined, please make sure you are on mute. If you'd like to see the phone and audio broadcast instructions again, please refer to the confirmation email I sent to you today. Or if you go to the top left-hand side of your WebEx screen, you'll see a tab labeled Event Info, and some of those connection instructions are included there as well. Also, if you're not hearing anything, if you're not hearing the audio very clearly through your computer, there could be a bandwidth issue, and it comes in much better through the phone line, so I would suggest dialing in through the phone if that's the case. Additionally, once this webinar closes, a survey should pop up in your browser. It's a short survey. It shouldn't take more than 60 seconds. Fill it out. Tell us about your experience at today's webinar so we can continually improve these webinars for you. Okay, I think that takes care of some of our housekeeping matters. And to get started, I'd like to introduce our presenters. First, we have Andrew Brody. He's the Global Control Offerings Marketing Leader at Honeywell Process Solutions. He has over 20 years of hands-on process automation experience spanning several disciplines, including engineering, business development, sales, product management, and product marketing. He has industry knowledge from oil and gas production, pharmaceutical manufacturing, power generation, and discrete manufacturing. Andrew holds undergraduate degrees in Industrial Instrumentation Technology and Business Information Systems, plus an MBA in Technology Management. Last but certainly not least, we have Graham Nasby. He's a Water, Scada, and Security Specialist for a large publicly owned water utility in North America. He's responsible for the capital planning and day-to-day operation of the utility's geographically dispersed automatic control systems. He has extensive experience with the design and operation of industrial control systems, including both PLC, Scada, and DCS systems. He's a voting member of the ISA 18.2 Alarm Management Committee and a certified functional safety engineer for safety instrumented systems. I welcome both of our presenters, and I'm going to pass it off to Graham to kick off this webinar and to kick off our poll questions.
So thanks, Michaela. As Michaela mentioned, my name is Graham Nasby. I work for a public water utility. I'm actually located up in Canada. I've been working in the industrial automation sector for the past 15 years, and I've been in the roles of end user. I've worked on the consulting side. I've worked as a system integrator, and also worked for a vendor, both as hired help and also someone that designed automation systems. I currently sit in the end user role, and I'm going to provide some insight of PLC and DCS systems, and just over an overview of the characteristics of those systems and some opportunities with Industrial Internet of Things. Before we get started, there's a poll which we've brought up here, and this is to help Andrew and I get an idea of what your experience with integration with PLCs and DCS are. So there's 4 questions. I'm just going to read through them briefly. First one, are you currently using a DCS integrated to PLCs? That is, do you have a DCS where you have to connect PLCs to it? Second one, have you ever integrated DCS with a PLC? And that's going the other way around, which you do see in some sectors. Third one, have you ever participated in any applications which use Industrial Internet of Things? And the fourth one is, does your company or organization have a position or strategy when it comes to Industrial Internet of Things? Each of these has a yes/no answer. So you'll see a poll. It's on the right-hand side of your screen. You fill that out. That will help guide Andrew and myself as we present the talk today. I'm just going to move to the agenda for today's talk. So we're starting off with the introductions. We've got that pretty much licked. I'm going to give a talk about pros and cons of integrated solutions when you're looking at PLC, DCS systems, and everything in between. I'll give a few thoughts on how to connect Industrial Internet of Things devices. And then I'm going to hand things over to Andrew, and he's going to give a talk about some of the opportunities that Industrial Internet of Things provides and some of the things you want to look at when you're integrating them into a traditional DCS or PLC, and some of the features that you need to do that successfully and maintain those systems. As Michaela mentioned, we have a Q&A session, which will go at the end of the call, and then we have a survey at the end to let us know about these webinars and what we can do to make the next one even better. So I'll just give you a minute or two to finish filling out the poll, and then we're going to move to the technical part of the talk, which is pros and cons. And this talk is going to follow an outline, which will start with an overview. We'll look at the anatomy of a modern control system and the layers it uses. We'll take a look at what a traditional PLC or PLC Scada system looks like, what a DCS system looks like, and then highlight a few of the integration challenges. We're going to dive into different layers of these systems and talk about some of the things that you need to do to get these systems up and running and to maintain them. We'll talk about some core features where we have HMI screens and alarms, bringing data into the higher level systems, such as corporate and IT, and then start talking about Industrial Internet of Things. And that's that awkward acronym, IIoT. That always seems to be a bit of a mouthful. And I will try to use IIoT or Industrial Internet of Things throughout the presentation. So we might as well close the poll now, and let's get started. So if we look at our typical industrial control system, there's a number of components that we have. We have the field equipment. These are your analyzers, your instrumentation, your valves, your pumps, your control surfaces, any measurement instrumentation you have. You have the wiring that brings that into the control system. You have the controllers, whether it's a PLC or an RTU or an RTAC unit or whatever the vendor happens to call it. It's the box that all the instrumentation hooks into. That box will also have a control program on it as well, which does the automatic control. You have a control system network. You'll have various servers depending on the architecture of the system. You'll have operator view stations. And the way these systems work is you have data tags, and the data tags contain your measurements or your control variables, and these data tags are moved back and forth, and that's what controls your process. You'll have an alarm system for calling out alarms, either to a control room or to a roving operator. You'll have a historian for doing trending and data analysis, and there'll be a reporting component. So if we take a look at our poll here, it looks like we're about 50-50 for a number of people who have done DCS integrated to PLCs, and about 50-50 for people who have done it the other way. We have a number of people here who have done integration with Industrial Internet of Things, but that's only about 20% of our attendees today. 80% have not worked with Industrial Internet of Things. So I hope 80% of this call is helpful to give you an overview. And for those of you who are already doing it, I hope this call highlights how you can leverage those assets even more. at whether a company or organization has a position or strategy, it's about an even split between yes, no, and not sure at this time. So it looks like there's some good opportunities for today's webinar. So let's take a quick look at what a traditional PLC or PLC Scada system is. And as I just mentioned, Scada means supervisory control and data acquisition. These systems are used in a number of industries. In the water industry, typically Scada means anything for the control system. If you're looking at the upstream and the oil and gas sector, it typically means a remote well site or a remote compressor station. And you see definitions all in between of what Scada means. But Scada basically has controllers, which are PLCs out in the field, and then another software application which runs on top in the traditional sense. So if we look at this from bottom up, we have our instruments and devices. We move up to our field wiring. We have PLCs, and you'll see on the drawing here, they're called RTUs, or remote terminal units. You'll have a number of servers, and the first one being the I/O server, and this is the one that gathers all the information from the PLCs or sends data tags down to the PLCs. You'll have a number of other servers, so you'll have usually an application server, there'll be a historian, and then alarm servers or whatever functionality is required. All of this connected with a process network. You'll have view nodes, which your operators will work with, and then you'll have a connection up into other systems, higher network. Now, let's take a look at what a DCS system looks like. You'll see a very similar structure, but there's usually not as many moving parts. Traditionally, a DCS is usually a single vendor. There's a controller, which is implemented into the servers as well. It all comes from one programming environment. At the bottom, you still have your instruments and devices. You have field wiring, then you have controllers. You have a process network, just like the Scada system. Usually it's a little bit more integrated, that network. You'll have various servers. You'll have a historian. You'll have what they call an engineering workstation. Usually that's a designated computer for doing programming of the DCS, whereas on the PLC side, usually they're external tools or laptops you connect to individual devices to program them. You'll have operator terminals as before, and then other systems at the higher level, usually protected by a firewall and router, and sometimes multiple firewalls. So, bringing this all together, if you look at a modern control system, it's a triangle. So you have device control down at the bottom, you have your controllers above that, you have supervisory control on top of that, and then your higher level systems. So if we look at this from bottom to top, you see a common theme here of layers. So let's take a look at these layers one at a time. So if we first go to the I/O level, these are the panels that you typically see in a plant or a platform or a site. You'll have your hardwired I/O, you'll have visual inputs and outputs, you'll have analog inputs and outputs, voltages, currents, contact types. These details have to be sorted out. On some systems, particularly on the DCS side, you'll see field bus. So you'll see Profibus or Foundation Field Bus or ASIBus, and HART is used in a lot of these systems. And you'll have network connectivity to some devices. Some devices, say a process analyzer, may have a network connection that goes directly into a controller. So if you look at this from an integration point of view, you've got to select your I/O types, you've got to pick your cards, you have to do the electrical design, your programming, scaling, and setup. PLC systems, typically you're doing this point by point. DCS, there's usually a few more tools to help with this. Now, as we move up, let's go to our controllers. So both PLC and DCS systems have controllers. Usually on the PLC side, the controller is its own entity. It's not part of an integrated environment. It'll have tags or memory registers for programming it. Some PLCs will have support for function blocks or reusable templates. Some don't. One of the aspects you'll see in PLCs is you can customize a PLC pretty much any way you want, but you have to write a lot of code, and they can be quite labor-intensive to program. Whereas on the DCS side, typically they use templates or widgets, so you'll assemble the modules together, and then you don't have to do as much low-level or custom programming. And as in this talk, I'm highlighting the differences between the two systems, but there's a lot of similarities. In the old days, PLCs were very simplistic for programming, and there was no use of templates in them. In the old days, DCS were very block-oriented and very inflexible. You had to do it using the modules or you couldn't do it at all. What we're seeing now is a lot of the features from the PLC are coming into the DCS, and features from the DCS are going the other way. So a lot of times you'll see a system, and you're not sure if it's a PLC system or a DCS system. It may be a hybrid system. This is one of the ways the market's been moving to lately. So now we have the process control network, and this is the network that ties together all the controllers and the servers. If you have a stick-built system or a PLC system of multiple components, all of that network infrastructure usually has to be managed independently. And then if you go to a more integrated system, typically there will be tools provided or there'll be standardized hardware used to make the management a little bit easier. And depending on your application, your process control network can be quite straightforward or it can be quite complex. It really depends on the size of the plant in your application. So in between the PLCs or the controllers, you'll find your data servers. And this is what brings the data from the controllers or the PLCs up into the control system. So on the PLC side, typically you have a data server has to be configured for each of the PLCs. Often you'll have to create a separate tag database or I/O list that is programmed to talk to the PLC as in opening up data channels. And if you have multiple types of PLCs or multiple locations, sometimes you have to do quite a bit of configuration to get it going. Now on the DCS side, typically there's very little setup. There's an integrated programming environment, and this is handled at the controller level. One thing to note here is that if you're using non-standard devices, this is where industrial Internet of Things comes in. Sometimes getting the data server level can be a bit time-consuming to set up, especially if there's no monitors or toolkits that make this type of communication separate. As I mentioned, most control systems use the concept of a data tag for bringing in information. An IIoT device is a much richer piece of control equipment. You can have a lot more information, so setting up hundreds of tags for one device may not be the best way to talk to it. And there are protocols in IoT to make this work better. So it's something you want to look at when you're selecting an automation system. Moving up further, let's go take a look at our HMI screens. These are the operator interface terminals that operators will use to interact with the system, both under normal operations and when there's a plant upset. This is their view into the system. So in a PLC data system, this is usually set up so that the screens are usually a separate development environment. They often have to be programmed on their own, and the amount of custom programming requires varies by the system. Whereas in DCS, as I mentioned, it's usually an integrated environment. So when you're programming the controller, you're often setting up the screen at the same time. And there's usually toolkits to reduce the amount of programming effort. Now, one area of control systems that is very important, whether you're using a traditional system or you're working with IIoT, is the alarm system. And this is where notifications are sent out to operators telling them that something is not right and they need to respond to it. And any modern control system will have an alarm system in it, and there'll be alarm trigger conditions that are programmed, whether it's the base alarm condition, whether it's filtering logic, such as an alarm for low pressure will only happen if a pump is running. As in, there will always be low pressure if a pump isn't running, so only tell us if the pressure is low if the pump is running and something's wrong. It includes filtering the alarms, saying to the right operator. And PLC and DCS systems have varying levels of support for this. Some have built-in systems, some require third-party software. Some have a lot of features in this area, some not so much. So when you're picking your system, you want to look at carefully how you want to use alarms. Now let's take a look at connectivity. As I mentioned, there is a pyramid when you look at control systems, with the devices at the bottom and then higher level systems above that. So we can't run a control system in isolation anymore. Folks in the business office and production scheduling need to know what the state of the plant is and how we're operating, both in terms of throughput and efficiency. So some of these systems you connect to is a general reporting system, enterprise planning tools, scheduling, billing and ordering, accounting, maintenance management, And there's many different protocols and methods for connecting these systems. And security between these systems is important. You want to make sure that only systems that are meant to speak to each other do that and do them in approved ways. So this is an area where you want to be very careful when you're looking at your control system to ensure it has the connectivity that you're looking for. So let's do a quick review of pros and cons of traditional PLC systems and DCS systems. So from the PLC side, one of the big pros is traditionally the hardware for these systems is usually very inexpensive. They're very customizable, but the con is you're going to spend a lot of time doing programming. And sometimes if you want to program a very complex device, doing a PLC may not be feasible because it's simply about the sheer amount of programming required. Some PLCs have limited support for modules, templates, or function blocks. And when you're working with HMI, sometimes you're duplicating effort because two tag databases need to be created. And lastly, in some of the PLC systems, the way they name data tags is quite restrictive, and this may be difficult to produce systems that are easier to maintain. But traditionally, PLCs were very inexpensive, and these drawbacks made it worth it in that area. Now, we look on the DCS world. The DCS world, the distributed control system, one of the great things that has tons of features. Traditionally in the past, though, these systems have been very expensive, which has been their main drawback. But if you look at life cycle cost, you had an integrated development environment. You have lots of templates and reusable modules. You don't have to do a lot of custom programming because there's modules for it. You have a lot of troubleshooting and management tools available. And you usually have a single point of contact to talk to if something's not right. But as a downside, traditionally they were quite expensive. However, as the markets develop, you will notice that PLC systems and DCS systems are starting to become more like each other. A lot of the features that you'd find on the DCS side are showing up in PLC systems, and likewise the cost of DCS systems continues to come down. So let's look at Industrial Internet of Things. This is a really big change in our sector. Traditionally, we looked at equipment just in terms of data values. So if you looked at a level transmitter, the only value you could get from a level transmitter was what is the level in this tank. However, if you look at a level transmitter that's implemented as Industrial Internet of Things, you could look at that transmitter, get a copy of its configuration. You could look at its performance over the last month. You could look at the temperature of the transmitter. You could look at individual alarms you could program at the device level. You could do diagnostics with it. And you could look at a myriad of other features that vendors are starting to provide in these devices, which is a lot more than a single data type. But here lies in the challenge. What is the communication protocol we are going to use to talk to that device? The traditional single data value is not going to cut it. Also, what if that device has something very unique to it in terms of troubleshooting modes or adjustment modes that are not part of an established industry protocol? How are we going to bring that in? You have to look carefully at what device driver or connector code is on the PLC or DCS system that you're looking for. If you have modules or toolkits to connect these to these new IIoT devices, it'll make it much easier, and you'll be able to accomplish the goals you're after. I guess what I'm saying here is when you're looking at a control system selection, you want to look at what are the individual requirements that I have at my plant, what do I want the system to do, and what type of return on value or extra functionality do I want to have to be the one to leverage the system I'm putting in. So you want to use the requirements that you have to drive the system and make sure the system has modules and features to support that. So here is an introduction on PLC and DCS systems. I'm going to turn things over to Andrew now, and he's going to talk a little bit more about Industrial Internet of Things and some of the opportunities that makes available. Thank you.
Hey, thanks, Graham. Really appreciate it. So, yeah, Andrew Brody here. I'm the leader for kind of anything kind of less than the big Experian PKS, the big DCS at Honeywell in terms of control. So I cover a lot of our strategy, marketing, product management around PLCs, RTUs, loop controllers, that class of product. So we're really excited kind of where this technology is heading. We've got a big initiative going with our PLC, and that's kind of where we started getting into, you know, what's it going to take to get in with IIoT and kind of start putting this into products to just make it easier for our customers. So one thing we see here is the industrial Internet of Things. It has the potential to be the most significant development in automation systems since the introduction of distributed control systems. It's got a wide range of potential uses and benefits: faster configuration and commissioning, leveraging data from dispersed enterprises, proactive remote asset health monitoring, improved collaboration. I'll just kind of dive into a couple of these quickly. So the proactive remote asset health monitoring, we're already starting to see this pop up in kind of packaged units and high-value pieces of equipment. So I've seen it show up in stuff like medium voltage drives, where vendors are starting to offer kind of remote connectivity into the units, as well as kind of standard templating around the data models for these systems. I think that's going to be another thing that kind of comes up more and more. We're no longer talking about single values like levels or temperatures, but essentially a whole kind of data model or set of information responding to it. And especially we're going to see this more and more for kind of repeatable items. So a medium voltage drive from the top level, that can be very repeatable. We're starting to see it happen in stuff like rod pump controllers. So these are kind of the control systems that you see out at the well pads that are moving the beam lifts or pump jacks, kind of controlling them moving up and down. So kind of fixed data sets associated with them that, you know, lend well into kind of maybe a secondary type user looking at it. So not just the, say, the plant or the Scada operator, but maybe some specialist third-party organization that can really help out with the company. So that's kind of another thing that we see with IIoT, is that it's maybe not just the vendor, it's not just the plant or the kind of the end user that's going to consume the data, but also maybe a supporting vendor that can kind of give some extra expertise. And that kind of also plays into this improved collaboration. It's just kind of allows a tighter link between manufacturers and third-party experts as well as the customer. And then the other thing I'd like to kind of talk about is kind of the faster configuration and commissioning. It kind of combines improved collaboration, but I'll give you an example here. So if we kind of go with that theme of some type of packaged asset, one of the jobs I worked on was a solar tracking controller. So these were for big concentrated solar thermal power collectors. So essentially these big parabolic troughs concentrating light onto a tube filled with synthetic oil. The trick for commissioning these things was making sure they could track the sun properly. And in the particular unit I was working on had these 20,000 pound hydraulic rams on them. So really big hydraulic rams tracking very, very slowly. So we were literally flowing about 4 ounces per minute of fluid into it. So it had a very, very specialized valve to do this, and it needed a special control algorithm to keep it on sun. So only a few people in the country really knew that type of system and how to do it. So at the time I was out of the Atlanta area, and the tracker was out in California. And through internet connection down into the controller with the configuration and tuning software, I was able to get that tracking to about kind of 0.05%. You had to be 0.1% or better to really harness the sun fully. But it allows for that type of implementation where maybe not only do you have local personnel that are good on day-to-day, but then you can really tie in these external experts to deliver some extra value out of it. So kind of see this on packaged units, high-value assets, and then especially stuff that you can kind of do data models around, and then that'll probably bring us into that what we can do to leverage the data. Once we have those data models, then certainly we can start doing all types of third-party analytics. We can start bringing it to the cloud for further analysis, and that really kind of starts to, really offer kind of game-changing type scenarios. And especially if we take a look at data from dispersed enterprises, something like, say, that medium voltage drive. So imagine you're the kind of the vendor that has the medium voltage drives. You're able to collect the diagnostics. You got the appropriate agreements in place with, say, several large oil companies. Well, then you could start seeing how they function across these several large oil companies, see what's breaking down, see their use case scenarios, and then you could turn that around to offer better medium voltage drives and give your customers more uptime. When that type of scenario is presented to even competitors, they understand, hey, I want to produce oil as efficiently as possible, as much uptime as possible. If I share a little bit of this data, I'm going to get more robust, effective equipment. So that's kind of another neat way that this is going to come about. So broad range of potential uses here. We see the industrial Internet of Things has the potential to be the most significant. Oh, sorry. Wrong slide on my other end here. Okay. So with the specific benefits, PLCs with the IIoT capability can provide the following types of advantages to our customers. We see it enabling businesses to leverage vast amounts of data, providing operations personnel with improved remote monitoring, diagnostics, asset management capabilities, enhancing data collection even in most dispersed enterprises, improving decisions about the actual health of assets, reducing the time, effort, duration, commissioning, minimizing need for troubleshooting devices in the field, bringing new production fields online faster, and generally improving collaboration across the company. Some of the concerns around utilizing IIoT include safety and security, connectivity, compatibility with existing network technologies and devices. We also feel that the challenges to adoption, they're readily surmountable with the right partners. So there's a couple things that needed to change. I think Graham alluded to it a little bit to kind of make this easier to implement. And one of the big things is kind of around how are we going to do this type of communication. In the past, there was a lot of OPC Classic, I'll call it, that was used, and that typically required the model that Graham was showing, where you'd have, say, your controller, then you'd have something like a I/O server, and then you might have your Scada DCS platform where it was kind of normalized through the I/O server. So say an OPC Classic type server, typically a piece of software running on a PC somewhere, translating, say, the machine protocol, stuff like Ethernet IP, Modbus, Profibus, into something that the Scada system could interpret. And typically OPC was a common mode for that. So what we're seeing here is Opc Ua is kind of a new platform that's coming out for us that is really going to help. And we're seeing that because this is kind of, say, divorced from the original Microsoft technologies that were present in kind of the original OPC, we're now seeing that this is able to be embedded into devices. So rather than a separate software layer sitting up at the, say, server level, we're able to now have PLCs with Opc Ua embedded. So Honeywell's kind of first PLC we're coming out with now has the Opc Ua embedded directly onto the PLC. So it's kind of eliminating one extra kind of bill of material part, one extra thing to troubleshoot. It's just combining it straight onto the controller. So what you're going to see in kind of these IIoT connected or capable controllers is you're going to see that you're now able to reach directly down from your Scada or DCS system in not just kind of a point-by-point basis, but Opc Ua actually supports full kind of objects, kind of that data model type stuff I was talking about. So now it's going to be possible to have, I'll give you an example, something like, say, a PID loop. Typically, there's 25, 50 subpoints, subtags associated with that. So now that can become kind of a small data model that now gets matched up at the Scada level with something like a PID faceplate. So DCS has had this for quite a while now. Now you're going to see this faceplate to kind of Scada HMI server level mapping become possible through some of these protocols. The other thing that Opc Ua kind of brings along for the ride with it is it's very kind of internet friendly, and it's got a couple implementations. One of them is a binary protocol that is very fast. So now it enables stuff like controller-to-controller communications and lower latencies when you're, say, pushing stuff up to the cloud or doing virtual engineering from the cloud. So that's going to be kind of something nice that's going to come along for the ride as part of this overall technology. Okay, so kind of getting to another part of our overall talk here is, okay, so you're trying to integrate all this together, and especially if you start having multiple PLCs and DCSs going, coordination among several vendors can present a lot of risk to implementation of the project. Some of the challenges we see are communication problems, resulting error gaps. They can be alleviated by using a single vendor for design and installation of the PLC as well as the overall control system. So if the vendor is making both the DCS and the PLC, there's a lot of background work there that can be taken care of to make sure that the stuff just works together and moves to a common configuration environment, and that the objects that we see down on the PLC, just kind of like they exist in the DCS world, are well represented up in the server. And then once we have this, we see that coordination is easier with fewer teams, direct access to system knowledge, resulting in faster system setup, testing, troubleshooting. Also, less hardware and training is generally required because you're kind of reducing some of your bill of materials and technologies you're dealing with. And kind of other things that we're seeing from this is the reliable integration. It reduces both the risk and the cost. There's just fewer coordination errors, less engineering, faster installation, less training, and once again, kind of the reduced hardware. A single vendor can provide kind of a single point of responsibility, so maybe kind of one finger to point, one throat to choke, one number to call when you're kind of doing some of these more advanced products. And once again, just it reduces risk, fewer elements to manage, and once again, that kind of single point of responsibility. Okay, so an integrated system utilizing PLCs with DCS can offer remote configuration and device monitoring on an integrated HMI, providing a single view across the operations. In addition, something new that we've already kind of brought to market with, say, our DCS, we're starting to see this find its way into the PLC space, and that's kind of a universal channel technology, universal I/O, software configurable I/O, and it enables the entire cabinet to become a standard part. So what I'm seeing with some customers now is they'll build up cabinets complete with universal I/O, and they'll do them with kind of a small, medium, and large type footprint. And especially kind of some of oil and gas customers, upstream customers that kind of do a lot of repeat work, they'll just build these, they'll have them in stock with maybe their local distributor, and then they'll deploy them and then just kind of customize the program per cabinet if they go out. And without kind of a universal I/O or software programmable I/O, this was a little more challenge for implementing these projects. So what we're seeing is engineers can quickly accommodate late configuration changes remotely with simple software configuration change. The universal I/O provides configuration efficiency, flexible design, reduces project scheduling, cost, and just overall risk. It also eliminates some of the tedious documentation updates for cabinet configuration and simplifies your overall maintenance. One more thing is the reduction in types of I/O modules reduces the numbers of spares. I'm sure a lot of you have been through RFPs, RFQs, trying to generate those maybe or respond to those, and there's always like a 10 or 20% spare type needed. So if you move to a kind of a universal I/O technology or software configurable I/O, then you don't need kind of the extra 10, 20% of a specific analog input card or a specific digital input card. You're able to just kind of combine a bit of that into a fewer amount of universal I/O cards. So another thing we're kind of seeing from this combination is we're seeing leaner control rooms. The operator effectiveness can be increased and the risk reduced. The common HMI for the PLC and the DCS system means fewer operator and engineering stations, less hardware and wiring, reduced IT licensing, and less training with the common interface. Your operators, technicians, engineers, they're going to make fewer mistakes because they're using one system consistently. The end users benefit from reduced cost over the life cycle and smaller footprint, and just kind of another theme is just easier maintenance coming out of this type of combination. So one of the points we talked about easier was kind of how this kind of enables collaboration. So what we see is data needs to not only be interpreted and organized, it's got to reach the right people, bring the people together where a range of inputs and value can be derived. And IIoT technologies and the integration between the PLC and DCS are they're key to this type of collaboration. Kind of that extra level, like where we see not only instead of just point level information, we're starting to group stuff into data models, trying to make it repeatable, reusable, and kind of treat stuff more as assets. And once you have the right data model paired with the right asset, then you can start deriving specific types of queries, watches, other things to kind of improve the efficiency or improve the kind of maintainability of the system. And so the availability of data results and operations able to run with dispersed workforce. I gave you a good example of that, me being in Atlanta and the tracker out in California. The internet-connected mobile devices, they can run increasingly sophisticated HMIs, and this enables users to manage and make sense of the data flow. And also just kind of a big part of this is just remote access to real-time contextualized information for workers that brings opportunities to radically decentralize the decision-making. So you can really have the best people on the globe helping to run your operations when this is properly implemented. So a big thing that's going to come up with this, if we're talking about more connectivity, we're talking about going across the globe, we've got to be talking about cybersecurity. And one of the things that we're seeing trend on this is, how can we add an extra layer of defense into the security, especially if you're going to be taking something like a controller, pairing it with, say, a cell modem, hanging it off the internet, in the case of that solar tracker, bringing it to me in Atlanta. You got to have something extra there. Traditionally, this has been covered by stuff like Barracudas or network appliances, certain things like that, or maybe little DIN rail mounted ones like Tofinos and so on. Certainly those are all good. Sometimes they add a little extra cost to the system. And if you can add another layer, then that's going to be even better. And especially if you're talking about the really dispersed stuff, then maybe the extra cost for a DIN rail mounted firewall, maybe there's just not room for that in the budget, but you still want some protection. So with kind of IIoT type connected controllers, we're going to see a few things kick in here. So we're going to see stuff like secure boot. This is kind of like signed and certified firmwares, such that unless you're, say, somebody like Honeywell that maintains the certificates for loading the firmwares, it's really next to impossible to go ahead and create these firmwares, update them. I'll give you a little example of that. Early in our development cycle of our kind of IIoT PLC, we were experimenting with this, and one of those certificates got lost. It was new. It was just one got lost. Well, that literally locked that controller in time. It wasn't possible to update that early prototype with the new firmware. Even the vendor couldn't do that without replacing chipset level stuff. So with that secure boot technology and the certificates, and of course for any vendors using this, they have multiple backups, globally dispersed, all that good stuff, so they can continue to issue firmwares. That really locks it in and prevents kind of insertion of malicious code at, say, the firmware level into these, because especially with PLCs in this class of controller, you're going to see several firmware updates throughout the life of the controller. The other thing you're going to see is a security in-depth approach is the built-in firewall. Just that extra layer for whether it's denial of service attacks or chattering on your network, overloading, say, the comms portion of your controller, and thereby maybe, depending on how segregated comms and control was, maybe slowing down your control or kind of causing issues there, so the built-in firewall. And then the other thing you're seeing as part of this security effort is the environment in which it's developed. So kind of the factory, the engineering cycle that was developed, is that a kind of certified secure development environment, so you make sure no malicious code actually got inserted during, say, the development of the firmware and the product. And then let's take a look at, once you get these, what are some of the ultimate benefits that combine with a PLC DCS type solution? We see kind of top and foremost, we're seeing that it's reducing costs, it's reducing risk, especially for greenfield implementations, and then overall unplanned downtime. The reducing time commissioning and minimizing troubleshoot allows early startups, long-term cost savings. In addition, there's reduced unplanned downtime associated with the ability to remotely diagnose equipment and implement remote health monitoring. So currently solutions are being developed to better integrate the devices. We talked about kind of the Opc Ua and some of the steps around and advantages that that's going to offer. There's going to be some, it's still relatively new in its cycle. At Honeywell, we're starting with, say, something like our PLC, embedding it there. We're then moving it into the higher software levels, like Scada servers and the DCS, and then ultimately into the higher levels, like, say, the historian and reporting systems. And, it's not just Honeywell that's doing this. There's a few others out there that are starting to do this. I've seen it in kind of competitive Scada packages out there. I've seen another PLC with Opc Ua embedded within it. So the real kind of strength and ability to bring all this together is really building quite quickly. I've seen really good adoption of this. And so that kind of Opc Ua is going to be something more and more to look for when you're going to buy your new controllers, because it's going to allow kind of this more and more data model access, connectivity, really traversing networks a lot faster than some of the traditional protocols have been able to do. So it's going to allow kind of big data, cloud environments, the virtual engineering to kick in a lot better. And as the technology develops, the challenges to adoption are going to be overcome. Solutions are going to become standardized. We just see the potentials continuing to grow. And then once we combine PLC and DCS technology, just look for a leading vendor who's really working with these together, and then they're going to be able to help you through some of the changes as this IIoT revolution kind of builds and grows out. So at this point, I'm going to pass the baton back to Graham.
Thanks, Andrew. Everyone, as Andrew mentioned, IoT offers a lot of additional functionality that previously wasn't really available in the PLC or DCS control world. You have rich data devices, you have additional functionality, and you have non-standard data structures which provide new interfaces and new insight into the equipment and instrumentation that we use. In the first part of the talk, we had an overview of the different components of PLC and DCS type systems, looking at the layers of how control systems are structured, going from the I/O down at the bottom, up through field wiring to controllers, through networks, into I/O servers, into various other servers, into view stations, the historian, and then connecting up into higher level systems. Andrew also talked about connectivity that's now available to have experts be able to dial into your system, service providers or vendors to help them maintain, build, and commission systems. When looking at modern control systems, you have to look at connectivity of how you connect to devices. Industrial Internet of Things has newer interfaces, and Opc Ua is one of these interfaces, which has proved to have a lot of market traction. You want to look at a control system that has connectivity for these solutions, not just on the protocol side, but also in terms of modules or templates to talk to various devices. But with all of this talk of features, applications, and opportunities, you need to look at what your individual requirements are. What do you want to do with your connected enterprise? What information do you want from your instruments? What information do you want for your remote sites or in plant? And use these requirements to pick a system which will allow you to leverage IIoT in a way that it drives you towards your goal, whether it's your company, organization, or utility, in my case. So I would take a look at the features that are out there and help that guide you in how you select, adapt, commission, and maintain modern control systems, as automation technology has great opportunities for enhanced return on investment and utilization of your assets. So with that, I'd like to move over to the question and answers part of our talk today. And as Michaela mentioned at the start of the talk, we are more than happy to take questions from the audience. And if you can write them into the Q&A box here, then we can take a look at them. So I'm just taking a quick look here to see what's on, and Andrew also was able to answer questions.
Yeah, so I see in the chat that Leonardo, Basiliani asked in the chat on how secure our devices against cyber attacks and how can we be prepared in cybersecurity issues. So covered a little bit of that on the cybersecurity page, but what we're seeing is you still need to do a kind of go through your typical audits, but also make sure you've got a security in-depth approach. And with kind of these IIoT devices, especially the controllers, we're going to go ahead and kind of embed a lot more security into those, starting from the actual development and design in those kind of certified development environments with the certificates and the firmware signing to make sure that kind of nobody kind of puts in a firmware that could have some malicious intent on it. I see some of that stuff would almost have to be state-sponsored to even come up with the firmware, but without that certificate, it's going to be really, really hard, even if you tried to make a firmware to land it on a controller without also having the certificate. The other things kind of going on with that is stuff like firewall, and the firewall is not just for malicious attacks. One of the kind of modes of failure for any kind of network-connected device is it can start spewing out a lot of junk onto your network. And with controllers, oftentimes they're using similar CPUs or connected somehow inside their operating system and programming. So if you overload the communication side, a certain amount of that can bog down the control side. So really making sure that that part there is properly segmented, that the firewall is kind of imposing a certain amount of, say, quality of service coming into the controller for communications. So it doesn't kind of infringe your core thing, which is your communication, and then maybe prioritizing what's going in, what's going out. Even stuff like who's able to even talk to it is going to start to get embedded into the controllers so that only authorized MAC IDs or IP addresses or kind of higher level certificates. Opc Ua allows for that as well to even talk to the device. So we're going to see more and more of that baked right into the controller. So you'll still be able to use all your traditional cybersecurity methods like network appliances, but you're going to be able to go ahead and get one extra layer all the way down to the controller.
So Andrew, I think I'm going to take the next question here, and we have James Clark who's written in. He says, does all industrial Internet of Things devices have a standard database? And he references ODB2, which is the connector that you find in automobiles for picking up the status of your car. And the short answer for that is no. And this is one of the challenges of IIoT, because every device has its own interface in terms of the actual data tags and the data points. However, as part of the long answer, the answer is mostly yes, actually. Typically what IoT devices will do is they'll use a larger protocol like Opc Ua or RESTful POST or other protocols, and those protocols allow for some flexibility in terms of how the data is structured within that protocol, and that's where the uniqueness of the device shines through. Where the core protocol, there are standard protocols that folks are moving to, and vendors as well. And if you're looking at IIoT and you're looking at a product that a vendor is offering, you should ask for that specification. And you can take a look at it, or you can have your automation expert take a look at it, and they can advise you of the connectivity options for that and what systems you can easily connect it to.
Yeah, I think Graham really nailed it there. You're going to see certain standard parts, like, say, the ODB2 connector. Well, in our world, it's going to be stuff like the Ethernet jack on it. If you're more a wireless fan, it's going to be kind of the ISA 100-based radios, or maybe wireless HART, if that's what you're looking at. We're even seeing those two getting combined into single access points. So you're going to see kind of some of the transport technologies, Opc Ua, those are going to start being common in industrial Internet type appliances. And then the other thing is kind of like those data models. So now with Opc Ua, you've got a good transport mechanism for moving the data models. The data models will be kind of specific. So there might be, here's the PID controller data model. And that may vary between vendor. Maybe we'll get to the point where there's kind of a basic and advanced, where all people offer a basic data model for PID, and then the advanced that kind of gets into their secret sauce and diagnostics and other things. Where we're seeing kind of the data models already start to come into common devices like the like medium voltage drives. So from a vendor, all their medium voltage drives, the top level data model on that would start to look similar. Same with kind of the rod pump controllers, or kind of very domain-specific controllers. These aren't kind of maybe as fully dynamic as a PLC might be, because you could really configure that to anything, but ones that are more fixed in purpose, like a packaged piece of equipment that kind of get built, programmed once, and then replicated 1,000 times, those will all start to have their models. And then they'll use those transport mechanisms that we talked about, and you'll really get to see, once a data model's known, then you can start kind of doing all your diagnostics, all your extra reporting, just looking for commonalities and failure modes. It's going to be quite exciting. So that's really what I'm looking forward to.
So I'm going to take a look at a question here that Enrique Macy sent in. He says, do IoT devices use IP address to connect? And the answer here is yes. IoT is generally built on TCP/IP or Ethernet-based infrastructure, and so IP addresses are used as part of this. However, one of the caveats is in some networks, you'll use things such as network address translation or routing rules, where there may be some additional routing steps that the control system will navigate to get to a device. The device will be an IP address, but it may not be on a public IP address. It may be part of a private network or part of a routed network for security reasons. And that's something you'll do when you do the design of these systems.
I think a common example of that people might even see at their homes now and was in the news recently is web cameras. So certainly this is both industrial and home space, where to really hit that from the outside with your mobile phone, you probably had to go through a little bit of a configuration of, say, your Wi-Fi router at your house or something like that. So that's kind of an example of what Graham's talking about is you really only have one IP address from the outside, but then there's a second piece of information called a port. And what you can do is you can say, hey, anything that comes in addressed to this port. So think of the network address as that's the front door to your house, but now you want to go to a specific room. Well, that port is the second part of the message. And so that you can say anything that comes in addressing this IP address with this port, I want it to go to this device. And the router is able to kind of bridge between, hey, what's happening from an external IP address and how to direct that message to the correct internal IP address. And that's how your web camera, say from your home or your business, could make it out to the mobile client on your phone.
Okay, so we have another question here. It's from Gary Campbell, and he says, I work primarily in the pharma industry. Many of the individuals are afraid to initiate an IoT scheme due to difficulty in IT equipment validation. So it says, sometimes it's difficult to validate firewalls and gateways. It says, do you have any experience unique to pharma? I picked up on this question because I spent 3 years working in the pharmaceutical sector on facility design and a lot of automation. And what you can do with this is if you have a specific IIoT device you're looking at leveraging, if you talk to the vendor, they will often have a validation package. This is something unique to the regulatory environment of pharma that will help you with the validation parts, and that's IQ, OQ, and PQ for those of you who work in that sector. And often if you speak to an IT vendor or a process equipment vendor, you'll want to find one that has some experience in working in the pharmaceutical environment, and they will advise you on how to prepare your validation and commissioning paperwork to meet the requirements that are unique to that sector. Just like you would do in the pipeline sector for their requirements or for the nuclear industry. There's certain equipment you can use, and there's some equipment that is probably a little bit harder to commission and qualify from a regulatory point of view. One other question I did see come in here earlier, which came in right near the start of the interview, was someone asked for some examples of some industries where IoT devices are currently being deployed. And the area that I've seen this come in is a lot with large rotating equipment. So in mining, large pump stations in the oil and gas sector, large things in chemical plants, and also in the municipal sector where we have had very large pumping stations with 2,000 or 3,000 horsepower pumps, which we do use in some of the larger cities. IoT is being used to monitor the status of those motors and the controllers, where that additional troubleshooting information and equipment monitoring information can be brought into the control system to make better use of those assets and alert personnel when an asset's having trouble, where there's more vibration or a bearing is getting warm. Basically, the areas I've seen this is where you have expensive pieces of equipment or expensive processes and you want to get additional information, and IoT is well suited for that.
Yeah, and to add to that, I think I already mentioned kind of out on the well pads for the rod pump controllers as one example, but another example I've seen is kind of going back to that dual customer model. Let me give you an example. Say you're a hospital or you're a plant of some type and you're consuming gases or chemicals. Well, there's kind of two customers really for that type of information. One, you as, let's say, the plant operator need to know what your inventories are so you can tell what batches you can make. But the other that would really be interested in that and probably really help with things is if the supplier of the gases or chemicals had that information. And so they can start monitoring levels or whether it be pressures on gas tanks. So kind of more of a monitoring Once again, that kind of secure way to bring stuff out. You might even see stuff like, say, dual network ports on it, one for the plant, one that could also be dedicated and locked down to the supplier. So for that type of industry, it's typical ones I've seen using that are water. Sometimes they have certain chemicals that need to be supplied. I've seen it in kind of like well treatment. So there's various chemicals they have to put down the wells and so on in order to kind of keep them flowing and not corroding and, kill off the bugs, so to speak. And then other places that kind of do a lot of batching chemical, stuff like lubrication plants and stuff like that, where they're kind of focused on making the lubricants, but they have a lot of feedstocks that go into it that they often get from kind of a wholesale vendor or some other vendor to bring it in. So can share the information just to make sure the right stuff comes in on the trucks at the right time. The one place is with terminals. These are where you might see oil, you might see molasses, you might see sugar. There's all types of things that can be stored in these tanks that then get loaded onto trucks to head off to various different companies. Well, in this case, it's not just the terminal provider, but it's also the trucking company potentially, as well as the end user that can look around to find some of these stocks. So yet another reason to move some of these inventory levels through your control system up onto the internet and let people go ahead and nominate selections of it, make sure if their truck shows up there that there's actually going to be something for the truck to get filled. So that's kind of another place where kind of there's multiple users besides just the local plant for the information.
So Andrew, I just took a look at the clock. I think we're out of time for today. Is there any final thoughts you'd like to give before we pass things back to Michaela?
I'd just say, while you're looking out there, some key things to keep in mind is what type of cybersecurity statement are your kind of IIoT devices talking about? What's being embedded? Is there anything there that's going to kind of make you a little more secure when connected? The other is, how are you going to move that data? Is something like a technology like Opc Ua embedded, something that's going to see more and more adoption across the various devices across your network? Things to avoid, anything that's like too proprietary of a network, requiring like maybe equipment from only one vendor so you could make that type of connection. So, try to make sure stuff is leveraging standards as much as possible through its connection infrastructure.
Well, thanks, Andrew. Just on behalf of myself, Graham Nasby, thank you very much for dialing into the webinar today. If you have any questions for myself or Andrew, feel free to contact us by 2 email addresses on your, which is up on the screen now. And after today's webinar, there will be a brief survey. If you could take a minute or 2 and fill that out, that helps Andrew, myself, and Michaela prepare these webinars going forward on our continuous improvement process. So thank you very much for dialing in today, and I'll let Michaela jump in if there's anything else that she'd like to let you know about.
Great. Thank you both for such an excellent webinar. I think the rest of the audience can agree on that. If you did miss any portion of this webinar, we did record it. So if you can rewatch it or share it with any of your colleagues for future playback. And the link to the recording will be given to you either sometime today or early tomorrow. So be on the lookout for an email from me with a link to that recording. I appreciate everybody for joining us today, and we hope to see you in one of our future webinars.